Classwork 6-3. You can use synthetic division to evaluate polynomials. This process is called synthetic substitution. The process of synthetic substitution is exactly the same as the process of synthetic division, but the final answer is interpreted differently, as described by the remainder theorem. The remainder theorem states, if the polynomial function p of x is divided by x minus a, then the remainder, r, is p of a. For example, if you divide x cubed minus 4x squared plus 5x plus 1 by x minus 3, we're evaluating p of x at 3. Using synthetic division, we find that the remainder is 7. Since the value of the remainder is 7, the value of the polynomial, where x is positive 3, equals 7. We can double check if we plug in 3 to the equation x cubed minus 4x squared plus 5x plus 1, the answer that we get is 7. Let's do some examples. For number 9, evaluate the polynomial at x equals negative 2 using synthetic division. So our a value is negative 2. Our coefficients are negative 2, negative 13, 0 because there's no quadratic term, 31, and negative 8. Carrying down our first number, we have negative 2. Negative 2 times negative 2 is positive 4. Add the column, we get negative 9. Negative 2 times negative 9 is 18. Add the column, we get 18. Negative 2 times 18 is negative 36. Add the column, negative 5. Negative 2 times negative 5 is positive 10. Add the column, and our value is 2. So the value of the polynomial, where x equals negative 2, is 2. Let's try another one. If we evaluate the polynomial at x equals negative 3, that means that our a value is negative 3. Using synthetic division, we have to account for each of the terms in descending order. So x to the 4th, the coefficient is 5. X cubed, the coefficient is 23. X squared has a coefficient of 0 since there's no x squared or quadratic term. Negative 76 is our linear term, and negative 17 is our constant. Carrying down the 5, negative 3 times 5 is negative 15. 23 plus negative 15 is 8. Negative 3 times 8 is negative 24. Adding the column, 0 plus negative 24 is negative 24. Negative 3 times negative 4, 24, is positive 72. Adding down the column, we get negative 4. Negative 3 times negative 4 is positive 12. Adding down the column, we get negative 5. So our value of the polynomial is negative 5. Let's try one more. Number 9, evaluating at negative 6. We have 1 for a coefficient of x to the 4th, 8 for x cubed, 0 for x squared, negative 73 for x, and 0 for our constant. Carry down the first term, or first coefficient. Negative 6 times 1 is negative 6. Add down the column, we get 2. Negative 6 times 2 is negative 12. Add down the column, we get negative 12. Negative 6 times negative 12 is a positive 72. Add down the column, we get negative 1. Negative 6 times negative 1 is a positive 6. Add down the column, and we get 6. So the value of the polynomial is our remainder, which is 6.